This is our first question. X raised to 4 plus 7x cubed plus 7x square plus 3x plus q is exactly divisible by x square plus 7x plus 12. Then find the value of p and q. See, here we have p and q. We have to find the value of these two. And the only given thing is this polynomial x square plus 7x plus 12 is a factor of this, right? See, the first polynomial is exactly divisible by the second polynomial, means this second polynomial is a factor of this first one. Okay, so factor means, see, this is a second degree polynomial, so we can factorize it and we will find out what is the meaning. So first we will factorize this second polynomial. So here x square plus 7x plus 12 is the given polynomial, second polynomial. Here, which identity we can use? X plus a into x plus b, right? That is splitting the middle term. So x plus a into x plus b is x square plus a plus b into x plus ab. Okay, so we will compare these two. See here, the given polynomial 7 is in the place of a plus b. That is, sum of two numbers, we need it as 7. So sum is 7. And the product a into b, in product place, what we have here? 12. So product, we need it as 12. So product 12. So how will get it? Sum is 7 and product is 12. So we will check what all are the factors of 12. 1 into 12 is there. Then 3 into 4 is there. 2 into 6 is also there. See, like that. 2 into 6. So how we will get this 7? See, 3 plus 4 we will get as 7. So what we understand is, in place of a and b, we have 3 and 4. Because 3 plus 4 is 7 and 3 into 4 is 12, right? So the product of the numbers 12 and the sum is 7. It is satisfied by 3 and 4. That is, in place of a and b, we have 3 and 4. So we can write it as x plus 3, x plus 3 into x plus 4. Okay, I hope you understood. So first we have factorized the second polynomial. Now we will check what is the meaning of the question. See, the first polynomial is a multiple of this second polynomial, means if this is a factor of this polynomial, what we can say? P of minus 3 is equal to 0 and P of minus 4 equal to 0. The base is x minus a is a factor, then what? P of a is equal to 0. So we can apply this factor theorem over here. See, this is the second polynomial. So we can say x plus 3 plus 4 are factors of the first polynomial only when P of minus 3 equal to 0 and P of minus 4 equal to 0. So let us take the given polynomial as P of x. This is written here. Now we will check P of minus 3. That is, in place of x, we have to give minus 3. So it will become minus 3 whole raised to 4 plus 7 into minus 3 whole cube plus 7 into minus 3 square. Okay, then plus p into minus 3 plus q. This should be 0 because x plus 3 is the factor. So P of minus 3 is 0. Now we will expand this. 3 raised to 4 minus negative number is multiplied 4 times. That means it should be, finally it should be positive. So 3 into 3, 9, 9 into 9, 81. So this is 81 plus, see, 3 into 3, 9, 9 into 3, 27. 27 into 7 is here. 27 into 7. 189. So, and see here, negative is multiplied 3 times. A negative number raised to 3 means it is finally negative. Okay, negative number raised to 3 odd number is the power and negative is here. So it is negative minus 189. Then 3, negative 3 raised to 2. Negative number multiplied 2 times. It is positive. Final answer is positive. And 3 into 3, 9. 9 into 7, 63. So plus 63. Then here p into minus 3. That is minus 3p. Then here plus q is equal to 0. Now here 81 minus 189. So actually adding two numbers, one is positive and the other is negative, and the bigger one is negative, so the answer is also negative. 181 minus 81 we have to do, thus we will get 108. So it is minus 108. Then we have to add this plus, right? Plus 63. So again minus 108 plus 63, adding a positive and negative, and still here also bigger one is negative, so 108 minus 63 we have to do, so we will get it as 45 and negative 45, because 108 is bigger one and it is negative. So minus 45 minus 3p plus q is equal to 0. Now we will get the equation. We need an equation, so we will get it as minus 3p plus q is equal to 45. What I have done is negative 45 is taken to the other side, thus it became positive 45. Thus we got an equation. Let me here. We will solve the second condition, that is p of negative 4 equal to 0. Then see, here we have to apply minus 4 in place of x. So what happens? Minus 4 the whole raised to 4 plus 7 into minus 4 whole cube plus 7 into minus 4 square plus p into minus 4 plus q is equal to 0, because x plus 4 is a factor. We have got it here, no? X plus 4 is a factor. That is why we are taking p of minus 4 as 0. Then minus 4 multiplied 4 times. Minus 4 is raised to a power 4. Even number is as the exponent. So minus 4 raised to 4 is positive. 4 into 4, 16. 16 into 16. That is 256. Okay. So 2, 5, 6 positive. Then here negative number raised to 3. Finally, it is negative. And 4 into 4, 16. 16 into 4, 64. 64 into 7 we have to do. 64 into 7. 448. Right? So it is negative 448. Then plus, see, negative 4 raised to 2. Negative 4 raised to 2. It is positive. 4 into 4, 16. 16 into 7. We have to do 16 into 7. 112. And it is positive. Right? So plus 112. Then here it is negative 4p plus q equal to 0. And now what we have is 256 minus 448 plus 112. We have to solve that first. So 256 plus minus 448 is 448 minus 256, that is 192. Then minus 192, because the bigger number is negative. So minus 192 plus 112, that is 80. And it is negative because 192 is bigger. Okay. So it is minus 80 minus 4p plus q is equal to 0. In order to get an equation, we will rearrange. Minus 4p plus q is equal to 80. Now let us solve these two equations. So we have written those two equations here. Then we subtract first from the second. Second equation minus first equation. What we get is q will get cancelled, right? Here plus q, here also plus q. When we subtract, this will get cancelled. Now minus 4p minus minus 3p is there. Minus 4p minus minus 3p. See, when two negatives are coming together, it will become positive. So minus 4p plus 3p, that is minus p. Okay, minus 4 plus 3, that is minus 1. So minus p. Minus p is equal to 80 minus 45, that is 35. So what we get is p is equal to minus 35. Okay, when we apply this value p in any of these two equations, we will get the value of q as well. So let us take the first equation itself. In the first equation, the relation between p and q is given as minus 3p plus q is equal to 45. And now we have got the value of p. Let us give it here. So minus 3 into minus 35 plus q is equal to 45. So next we have to multiply minus 3 and minus 35. Two negative numbers when multiplied, we will get a positive number, and it is 105 plus q is equal to 45. So in order to get q, we have to take that 105 to the other side. So 45 minus 105. That is actually 45 plus minus 105. Okay. See here, it is an addition of a positive with a negative number. So bigger one is negative. We have to subtract smaller from bigger. So like this, it is 60. So the answer Q is negative 60 because the bigger one is negative over here. This is our second question. If alpha, beta are the zeros of p of x, this polynomial satisfying the relation alpha square plus beta square plus alpha beta is equal to 21 by 4, then we have to find the value of k. Alpha, beta are the zeros of this polynomial. So p of x is here. P of x is 2x square plus 5x plus k. Alpha, beta are the zeros. So we can write alpha plus beta minus b by a. So in place of a, here we have 2. So a is equal to 2, b is equal to 5, and c is equal to k. So alpha plus beta is equal to minus b by a, which is minus 5 by 2. Now, alpha beta is c by a. Here c is k, so k by 2. Now, the given relation is alpha square plus beta square plus alpha beta. So, alpha square plus beta square plus alpha beta is equal to 21 by 4. Okay, alpha square plus beta square. We can use the identity because a plus b, the whole square, we know it is a square plus 2ab plus b square. So, what is a square plus b square? A square plus b square. See, here we have to take this 2ab to the other side. It is a plus b the whole square minus 2ab. Okay, so we can use the same identity over here. Here we have alpha square plus beta square. So we can take it as alpha plus beta the whole square minus 2 alpha beta. Okay, alpha square plus beta square, we can take it as alpha plus beta the whole square minus 2 alpha beta. Okay, now we have not taken it completely, mean we have to take this also, right? Plus alpha beta is left there. So plus alpha beta is equal to 21 by 4. This is the given data. Now minus 2 alpha beta plus alpha beta, that is minus 2 plus 1 is minus 1. Right? Minus 2 plus 1. Here we have a 1. Normally we won't write that. Minus 2 plus 1 alpha beta. Okay. So it is minus 1 alpha beta. So we can write it as alpha plus beta the whole square minus alpha beta is equal to 21 by 4. Now we can give the values alpha plus beta. Alpha plus beta is minus 5 by 2 and alpha beta is equal to k by 2. So alpha plus beta, in place of that we can give minus 5 by 2 the whole square minus alpha beta. See, alpha beta is k by 2. So we can give that value k by 2 is equal to 21 by 4. Now minus 5 by 2 the whole square. is minus 5 by 2 into minus 5 by 2. See, when we multiply two negative numbers, it is positive. So 5 into 5, 25. 25 by 4 minus k by 2 is equal to 21 by 4. So actually we need this k by 2 and here it is negative. So shall we take it to the other side so that it will become positive. So k by 2 is equal to, when we have taken k by 2 here, we have to take this 21 by 4 to the other side. So 25 by 4 is already there and this 21 by 4 is positive here. When it is taken to the other side, it become negative. So minus 21 by 4. See here, both these fractions have the same denominator. So we can simply subtract the numerator part. 25 minus 21 by 4. 25 minus 21 is 4. So 4 by 4 equals 1. So k by 2 is 1, or we can say k is equal to 2, because we can take this 2 to the other side. 2 into 1, 2. So this is the answer, value of k. Now this is the third question. Here, if alpha, beta are the zeros of this polynomial, find the polynomial whose zeros are 1 minus alpha by 1 plus alpha and 1 minus beta by 1 plus beta. Okay, so in order to get the polynomial, normally what we do is the required polynomial p of x is equal to x square minus alpha plus beta. Here alpha, beta are the zeros of some other polynomial. So let us take it as alpha 1 plus beta 1. Okay, into x plus alpha 1 into beta 1. Okay, this is what we need. And here in place of alpha 1, what is given? Find the polynomial whose zeros are this. So we can take alpha 1 as 1 minus alpha by 1 plus alpha. See what is given here. This is the zero of the required polynomial. And the second zero, beta 1, we can take it as 1 minus beta by 1 plus beta. Okay. And what is this alpha and beta? Alpha, beta are the zeros of this polynomial. Alpha, beta are the zeros of this polynomial means we can deduce the relation between alpha and beta from here. Okay. Alpha plus beta is minus b by a. Here in place of b we have 2 and in place of a we have 3. So it become minus 2 by 3. And alpha beta is c by a. Here in place of c we have 1. So it is 1 by 3. Okay, let it be here. We will apply it when it is needed. So we got alpha plus beta and alpha beta. Now we have to find this, right? Alpha 1 plus beta 1 is actually what we need to get the required polynomial. So these are alpha 1 and beta 1. So let us add. Okay, alpha 1 plus beta 1. Let us take the values from here. Alpha 1 is 1 minus alpha by 1 plus alpha plus beta 1 is 1 minus beta by 1 plus beta. Okay. Now, when we add these two, here the denominators are not same. So let us do cross multiplication. Okay. So what happens is 1 minus alpha into, see, we have to multiply this into this, right? So 1 minus alpha into 1 plus beta plus, because here we have a plus sign. Okay. Then 1 minus beta into 1 plus alpha, right? So 1 minus beta into 1 plus alpha divided by 1 plus alpha into 1 plus beta. 1 plus alpha into 1 plus beta. Okay, now we have to open the bracket and move. Okay, so here 1 into 1, right? 1 into 1, we get it as 1. Then 1 into beta, that is positive beta plus beta, minus alpha into 1, minus alpha into beta, minus alpha beta, plus 1 into 1 into alpha plus alpha minus beta into 1, minus beta into alpha minus alpha beta, all divided by, here we have to again open the bracket, 1 into 1, 1 into beta, positive beta, alpha into 1 plus alpha into beta, so plus alpha beta. Okay, see, we have the value alpha plus beta and alpha beta here, right? Let us take it. Okay. Okay, this is the value of alpha plus beta and alpha beta. Let us substitute these values here, and let us see, plus beta is here and minus beta is here. We can cancel minus alpha plus alpha, that is, we can cancel. What is left is 1 plus 1, so it is 2, minus alpha beta, so it is minus 2 alpha beta, divided by, here it is 1 plus alpha plus beta, just we have just grouped them. Okay, then 1 alpha beta. Okay, now it is easy to apply these values. 2 minus 2 into alpha beta is 1 by 3. Okay, 1 by 3 divided by 1 plus alpha plus beta minus 2 by 3 plus alpha beta 1 by 3. Okay, you see here, it is 2 minus 2 by 3. 2 into 1 by 3, 2 by 3, divided by 1 minus 2 by 3 plus 1 by 3. Okay, see, minus 2 by 3 plus 1 by 3. What is that? Minus 2 by 3 plus 1 by 3. See here, both have the same denominator, 3 minus 1 plus 1, that is minus 1. So it is minus 1 by 3. So we can write it as minus 1 by 3 here. And 2 minus 2 by 3 by 1 minus 1 by 3. Now, let us do cross multiplication. 3 into 2, 6, minus 2 divided by 3 divided by 3 into 1, 3, minus 1 divided by 3. See, on both part we have our by 3, we can cut them. Okay, 6 minus 2 is 4 and 3 minus 2 is 2. Sorry, 3 minus 1 is 2. So what we got it as 2. What is this? Actually, sum of the zeros of the required polynomial is 2. Now, again, we have to find the product of zeros of the required polynomial. Alpha 1 is here and beta 1 is here. We have to multiply these two. Okay, we have to multiply these two. Let be here. So next we are going to find out what is alpha 1, beta 1. So we are taking the values from here. Alpha 1 is 1 minus alpha by 1 plus alpha into beta 1 is 1 minus beta by 1 plus beta. Okay, when we multiply, let us take it as 1 minus alpha into 1 minus beta. See, just taking the numerators together and then denominators, 1 plus alpha into 1 plus beta. In the next step, let us open the bracket. 1 into 1, 1, 1 minus beta, minus alpha into 1, minus alpha into minus beta, plus alpha beta, divided by 1 into 1, 1, 1 into beta, plus beta, alpha into 1, plus alpha into beta, plus alpha beta. Okay, now, see, we can take, see here, both beta and alpha are having a negative sign, so we can take that negative sign outside, so we can write it as minus of alpha plus beta. Got it? Minus we have taken out because we have the values of alpha plus beta and alpha beta with us, so we can just simply substitute the values if we rearrange the things like this. And here beta plus alpha is also here, no? So we can write it as 1 plus alpha plus beta plus alpha beta. Okay, now let us take the values of this alpha, beta and alpha plus beta. It is all here. So let us take it there. Okay. Now let us just substitute these values in place. The 1 minus alpha plus beta is minus 2 by 3 plus alpha beta is 1 by 3 divided by 1 plus alpha plus beta is minus 2 by 3 plus alpha beta is 1 by 3. As we have done in the previous question, let us do this. Minus 2 by 3 plus 1 by 3. Both have the same denominator, just add the numerators together, minus 2 plus 1, minus 1 by 3. So it is minus 1 by 3. The denominator part, 1 minus 1 by 3. Now, here 1 negative together means it positive. So 1 plus 2 by 3 plus 1 by 3. Okay. Now let us check what is this. 2 by 3 plus 1 by 3. 2 by 3 plus 1 by 3. See, both the denominators are same. So we can add the numerators together. 2 plus 1, 3. 3 by 3 is 1. So we can just substitute it as 1. So in the next step, we will do that. It is 1 plus 1 by 1 minus 1 by 3. Now here 3 into 1, right? Cross multiplication 1 plus 1, 2 in the numerator part. The denominator 3 into 1, 3 minus 1 by 3. So here we have 2 by 2, 3 minus 1 is 2. So 2 by 3. We can cut these 2, right? And denominator is numerator, okay? Denominator is numerator. So what we got is 3 is the product of the new or the required polynomial. And in the beginning itself, we have written what we need, okay, in terms of alpha 1 and beta 1. See, this is what we need, the required polynomial, and we have got the sum and product of zeros. Sum we got as 2 here, and the product we got as 3. So let us substitute these values here to get the answer. So it is x square minus 2x plus 3. This is the last question of this video. If alpha beta are the zeros of p of x equals this, find the polynomial whose zeros are 1 plus beta by alpha and 1 plus alpha by beta. So it is almost similar to the previous question. There it was given in another way, only that much. So here also alpha beta are the zeros of this polynomial. So here we can write it alpha plus beta is minus b by a. In place of b we have 4. So it is minus 4 by, in place of a we have 1. So minus 4 by 1, that is minus 4. Alpha plus beta we got it as minus 4. Now alpha beta is c by a. Here in place of c we have 3 and in place of a we have 1. So it is 3. So we got alpha beta as 3. Okay. We will use it in the succeeding steps. Okay. Now we have to find another polynomial whose zeros are this. So the required polynomial p of x is, okay, p of x is used in the question, no? So let us take it as p1 of x. Okay, so it is x square minus sum of the zeros into x plus product of zeros. Okay, I have used another way of writing sum of zeros and product of zeros. That is what I have mentioned here. And zeros are given as okay, let us take it as alpha 1 as what? 1 plus beta by alpha, and beta 1 as 1 plus alpha by beta. Okay. Using this, we have to find the polynomial. So in place of sum and product, let us write it as write it in terms of alpha 1 and beta 1. Like it is alpha 1 plus beta 1. And it is alpha 1 into beta 1. Okay, so the next step is we have to find what is alpha 1 plus beta 1. Alpha 1 plus beta 1 is, see, we are taking the values or the things from here. 1 plus beta by alpha plus 1 plus alpha by beta. Okay, 1 plus 1, 2 plus beta by alpha plus alpha by beta. This is what we need. Okay, so 2 plus in the next portion. Here the denominators are not the same, so we will just cross multiply the things. So beta square plus alpha square by alpha beta. As we have discussed in the previous question, we can take it in terms of a plus b the whole square, right? So what was that? A square plus b square is same as a plus b the whole square minus 2ab. Okay, because we know the identity a plus b the whole square, a square plus b square plus 2ab. We are just taking that 2ab to the other side. Okay, I hope you understood. It was there in the previous question as well. Okay, alpha square plus beta square, we are going to use the identity 2 plus alpha plus beta the whole square minus 2 alpha beta by alpha beta. Now, actually we have the values of alpha plus beta and alpha beta here. We will take it now and we will substitute these values over here. Okay, so it will become 2 plus alpha plus beta is minus 4. So minus 4 the whole square minus 2 into alpha beta is 3 divided by, that division. This is for this part only, divided by alpha beta. Alpha beta is 3. So it is 2 plus minus 4 the whole square. Negative number multiplied 2 times it is positive. 4 square 16 minus 2 into 3, 6 divided by 3. That is 2 plus 10 by 3. Now let us take it, say 3 into 2, cross multiplication. 3 into 2, 6. So 6 plus 10, 16 by 3. This is the sum of the zeros of the new polynomial. Okay. Now let us check what is the product of zeros. This is these are alpha 1 and beta 1. We have to multiply them. Let it be here. So now we want alpha 1 into beta 1. 1 plus beta by alpha into 1 plus alpha by beta. Just opening the bracket, 1 into 1, 1. 1 into alpha by beta plus beta by alpha into 1, beta by alpha plus beta by alpha, beta by alpha into alpha by beta. Okay, this is the product of the zeros. Here, beta is here, alpha is here. We can cut, but this is not 0, right? All the terms are gone, but 1 is there as a silent part. So 1 plus 1 is 2 plus alpha by beta plus beta by alpha. Now here also we will do the cross multiplication. See, the denominators are not the same. So 2 plus alpha square plus beta square all divided by alpha into alpha square, beta into beta square all divided by alpha beta. Again we will use the identity. Okay, a square plus b square. So it is alpha plus beta the whole square minus 2 alpha beta divided by alpha beta. Okay, I hope you understood. This is from an identity. Now we have alpha plus beta and alpha beta with us as numbers. See, here we have the values. So we will take it there and we will just substitute. Okay, now when we substitute, what we get, we will say 2 plus alpha plus beta is minus 4 the whole square minus 2 into alpha beta is 3 all divided by alpha beta 3. So it is 2 plus negative 4 the whole square is positive 16 minus 6 all divided by 3. So that is 2 plus 10 by 3. Again, we have to cross multiply 2 into 3, 6. 6 plus 10, 16. So it is also 16 by 3. See, both Sum and product we got as 16 by 3. Right? Do you remember? The sum was also 16 by 3. Now, we will conclude. We have already written in the beginning what we need actually. We are searching for a polynomial like this. And both sum and product, we got it as 16 by 3. So now we will just substitute these values over here. So x square minus 16 by 3x plus 16 by 3. This is the required polynomial. Thank you. Hope all of you have understood.